This meeting is being recorded.
There we go. All right, now let's go ahead and get started. So it doesn't look like we have anybody from the foundation. Craig, do you have anything to share?
No, just preparing for presentations and stuff for the global summit.
Yep.
So that's it's coming up, but the big time for I did notice there was a birds of a feather agreement come for the table or something for a lunch or something. I haven't gotten the details or the day and the time, but I did see that they had said that they would do that.
Yeah, that was for our Edge group, right?
Yeah, it's for the Telco and Edge, I believe.
Yeah. Yep.
The combined group.
Yeah, so at least we'll have a table or something to get together at for the folks that are there.
Yep.
And then I had reached out to Dirk because I was trying to get a hold of the presentation materials that he did for the telco group for this MHS. Because I was hoping we could. My thought was that today we could start kind of going through that, but I got to poke him again because I haven't gotten anything back from him. So doesn't look like that's gonna be a topic we'll be able to talk about. So I'm wanting to be able to have that content so that we can perhaps start to review it and then think about what we want to, how we want to help contribute, because they do have sort of an edge aspect to what they're doing. And since I think we can actually maybe perhaps provide some requirements and input into what they're doing, that could possibly be a good way that we could help out. But no luck getting a hold of that content from him yet, so I've got to shake his tree and see if I can get that to fall out so I can have that so we can go through it on the call. Maybe next month I'll be able to get a hold of that. I did see, Craig, did you see that there was this thing about redfish? I don't know if this impacted us. Where was that?
No, I didn't see it.
Yeah, so there's going to be a thing on the 15th that John Young is sending out. He sent it out, I think, to the group. I don't know if that impacts us or not. I'll drop his email, the body of his email in the chat here. Bear with me. All right, so there I dropped it. Dropped it in the chat. Oh, here, let's see if I've got the. Here's the details. And let me see if I get that link too. Expose itself. So here's the link.
I see, but it's a DMTF meeting, so he just kind of forwarded that as it's not an OC. There's not really OCP.
Yeah.
Yeah. Okay. Yeah. Nice.
But other than
additions for NVMe.
Yeah, we were talking about
stuff. Yeah, okay. The latest extensions. All right. Nice.
Has anybody given any thought to you? We talked last time about this AI acceleration and that type of thing. Lucas, you've been working on this liquid cooling So it's kind of interesting to see. There's a lot of talk around AI and edge, and it's primarily around data sovereignty and protection, that you'd want to keep your data in some type of geographic regions for this AI. And so what seems to be kind of falling out is this whole idea of not only storing the data there, but perhaps training, especially looking at things like operational technology, which is a lot around robots and manufacturing, programmable logic controllers, SCADA systems, these types of things, where you'd start to want to kind of have these edge devices that start to employ AI. But not only is it sort of the just the generative aspects to it, but also the training, because a lot of these things will be kind of have to be trained on site, because each production line is different. Each environment that these robots in is different as well. So that starts to put a lot of additional overhead on the cooling aspects of running edge AI. And so that could be an interesting topic for us. What are your guys' thoughts?
Yeah, I think that this liquid cooling at the edge is an interesting proposition. It's different than what, for example, a lot of people are talking about heat reuse and large data centers where you need that large infrastructure. For edge, you could do this kind of cold plate cooling and then do a closed system instead of having a CDU. You have just the IT liquid on a single closed system. And then the things that you basically are increasing the area for heat transfer quite a lot and increasing the efficiency of removing the heat from the hot components. So it's quite interesting in that sense that you can, for example, design a complete package, and you, instead of having an air conditioning system, you could have this closed radiators system that you would be more similar to a air conditioning traditional system, like a house air conditioning system, where you have this indoor outdoor package. You could do something like that edge. This would be enable something like modularity if you need a complete package delivered there. This is something that I think is really interesting, and I have not seen at least too much development in that sense, because a lot of what's being done for the cooling in the other OCP groups, like cooling environments, are looking more at this idea of reusing the heat and then having this defining this data center infrastructure, where basically one of the big challenges that you basically need to uh, standardize all those connectors, which is a challenge. And also you need to standardize the liquids and the temperatures and everything there. So maybe a closed edge system, as you said, with this kind of application for AI would be more interesting, or would be a potential use for this kind of liquid cooling.
Well, it was interesting. I was in Murray Hill back in the beginning of July, and we went into the data center part, and there was a chassis that had a bunch of these NVIDIA H100s in them, and they're air cooled. And standing behind them, it was like standing in a wind tunnel. These fans were going so hard and so fast that, one, it was blowing an incredible amount of air, and it was very, very noisy. And so what kind of struck my mind is, oh wow, there's no way you could put this. It was bad even in a data center environment, because like you could hear it through the whole. You could and it would speed up and slow down depending on how the usage of the system was being taxed. So when it was under heavy load, it would all of a sudden speed up, and you'd hear all these fans kick into high gear, and then so it was constantly varying speed up and down. It was very annoying, very loud, and I was just imagining, if this is out in some edge environment, this is not going to be this is not sustainable. You could not do this if anybody was near. I'm kind of thinking like our traditional telco cabinets, and I've got one in here where I live, where we've got sort of all the AT&T fiber stuff in a cabinet, and even when you go out walking past it, it's not far from the sidewalk. You hear these fans going for just the equipment that's in there. And depending on where these systems are, and my thought was in sort of an industrial setting. If you start wanting to have to do this kind of thing on an industrial floor, it's just not. But what they're currently doing for the IT world with these fans, I don't think is going to work well. Just that was kind of my perception.
Yeah, and a lot of it comes actually from this area quality challenge, because you have this form factor that's usually some few units in this rack, and then you need to have small fans. So the compromise that you have to achieve is that to have enough air flowing, you have to speed these fans up, which require more power, and also make this loud noise as a consequence. So, for example, if you had a liquid cooling there, where you still could have this small unit inside your facility, but then with cold plates, you could remove most of that heat to an outdoor environment where space is not an issue. Then you could
Right.
have like a large heat transfer environment where you could have like a larger fan. And then the larger the fan, you can move more airflow without needing this much speed, basically.
Right. Yeah. 'Cause, these fans were probably about 6 inches in diameter, I would guess, about. And the chassis, you could probably fit about 4 of these in a normal size rack. And basically the whole back of them was filled with fans. It was like the whole back was just fans, and like your hair was blowing and your clothes were blowing, and standing back about a good 4 or 5 feet from where this was. There's just so much air velocity coming out of that thing.
Yeah, we had an interesting experience about this when we were doing this test with OpenEdge in the past, where we implemented cold plates, and basically we were just cooling the CPU at the time, but there was no limitation actually to cool, for example, a graphics card for AI training or any other specific part that's needed cooling in a server there. And what we compare to is that when we have OpenEdge with the fans at 100%, the sound level is basically to a lay person's comparable to being standing right next to a lawnmower. And then when we implemented the liquid cooling, we had this operating at full capacity, and the sound level, because we still had some air cool to cool the other components that are not being cooled, was comparable to having a normal computer on your per side, like a normal standard PC. Basically, the sound level was way lower. We had the fans at 20%, because basically, if you're cooling the CPU to this low level of temperature, it's also cooling the board. And the board is helping to remove the heat from other components there. So you have a path for the heat to flow. So you basically only need additional airflow to cool, in the case of OpenEdge, to cool the memories and some of the disks that are in the front. So it's just a auxiliary airflow there. And in that test that we did, we had this heat transfer unit that was outside, and basically we could run it from a window and have it running outside without being any compromise comparable to the amount of sound that would come if you had this air conditioning unit. So
Right. And like what you were experimenting with, those cold plates, is that like just a third party product that you could attach to other things, or did it have to be like custom designed for the specific chips that went on top of it, or like how did that work?
in that test that we did, we were using basically a standard component from EK, EKWB, I think it's the name of the company. But if, for example, you need better performance, or if you need to design to cool more components, then you might need to want to design your own cold plate. But it's no big challenge there. I think it's the cold plate part, the design of the heat transfer inside the cold plate is nothing like too much new technology, because basically the water has so much capacity to absorb the heat that you can get away with not having this a perfect cold plate.
Yeah. And so then like you just put like thermal paste on top of the CPU, and then this cold plate goes on top and replaces
In the test
cooler that you have.
that we did, in the test that we did, it was working like that. There is some technology like quite interesting there, where the cold plate is attached on top of the ship, and then you have this kind of jet cooling, where there is no, basically you remove this barrier between the cold plate and the ship, where basically you're pumping water directly on top of the heat spreader on the ship. There is some test, and there is a company that's doing that. That's quite interesting. I think it's JetCool, the name of the company, but uh, it's that would improve a lot of the cooling. But in any case, for the test that we were doing of OpenEdge, it was more than enough just to have this normal cold plate.
Yeah, it would be interesting to see if we could put a cold plate on some of these NVIDIA GPUs and see what that did to the requirements to need the fans. Because yeah, the fans are just not horrible. Yeah, so if we can get this thing from Dirk, we can talk about this MHS, and then maybe it might be interesting to also talk about, if we have modular CPUs and modular different other kinds of accelerators, because there's a lot of these there's a lot of, I think, innovation happening now that, people use GPUs because they were really a way to do parallel processing. But, I think there's a lot of new technologies coming out that start to look at, okay, maybe you don't need everything in the GPU, but you need to be able to parallelize the workloads. And so they're coming up with these different approaches to do AI without requiring, all the, video aspects of what you get with a GPU, for example. And so, I think that's kind of a moving target right now. Yeah, everyone's kind of gravitated toward the GPU because that was there. That's the software that was kind of developed. But it looks like there's a lot of work going on, especially with like Microsoft and what they're trying to do with these Copilot PCs and whatnot, where you'll have the capability to do AI sort of embedded in the actual CPU itself with these chiplets and some other things that could offer alternatives. So maybe you don't have kind of a stock Intel processor anymore. Maybe it's an ARM, or maybe it's an AMD or something else. But maybe something with this MHS concept could, I don't know, Craig, could that be something? Would that be something that would fit with that group, or would that be something else? So you probably have modular cooling along with these modular componentry.
I don't know. Maybe it might be part of one of the cooling route for that. I don't know if it has to go hand in hand with the modules or whatever, but obviously you have to have some cooling on those, but I don't know.
Yeah, I'm just wondering, like, is
Lucas may have a better, more of a thought on it.
Because like it seems like the cold plate idea is kind of modular, right? If you can kind of put this cold plate on different things.
Yeah, I mean, I think if you use the cold plate, you still want to reuse all the, tripless connectors and all that kind of thing.
Yeah.
It's part of the way it goes out of the back of the machine. And I mean, it's just piping coming in from the fitting to the cold plate.
Right.
I think.
But like, would you hook up, like, if you had like multiple things you were trying to cool, would you have these in series? Could or would you have to do them in parallel? Yeah, I would assume things further down the line, if you did it in series, may not be a good thing because it's going to be getting all the heat that was generated from stuff upstream.
No. I don't know. Lucas would probably know more about the plumbing aspects and that kind of thing of the cooling solutions. For sure.
Yeah, I think that it depends on how you manage the system because, for example, if in the test that we did, we had chassis with 5 servers and all the servers were in parallel. So they're receiving the same temperature. But what we noticed is that even if we put them in series, the heat escalation was not that high because in the system that it was designed to be like this test stand that we're doing, we could change the amount of liquid flow and we were able to achieve quite high liquid flow there. So it depends on how you design the system. You could actually have the system in series. There are some designs that they're using that because you basically can increase the liquid flow and then the heat increase is not that much between one component and the next.
Interesting.
Yeah, and about the tripless connectors, this is something that you basically need, Craig, if if you're planning to disassemble and reassemble the system on site. So basically, you need this kind of required to have this. But what I was thinking more for this edge and this application that John was mentioning, where you have, like, for example, AI training, you could design a modular system where you're not on site disassembling it, and then you wouldn't necessarily need the kind of just tripless connector. You could use this more common and cheaper connector where you design the whole system to operate, and then you could evacuate it from the CDU or basically from your heat exchanger. You could evacuate it from there, so that you would never actually be on-site disassembling the system. So you have this kind of modular data center with cooling integrated in it.
I see. Okay.
Yeah, but this is like some idea, but as I said, I've never seen anybody planning at least this kind of modular system for edge application. And in the other OCP groups, for example, cooling environments that I've been following, the discussion is much more about this kind of large liquid cooling facilities where the idea of reusing the heat is a lot of the proposal about using the liquid there.
Oh,
And
interesting.
in this environment, yes, you need these kind of triplets connectors and standards, defining standards about this liquid connection and everything.
Yeah, so the data center guys are looking at trying to what you could do to reuse the heat. Where
Yes.
the requirements that we would have from the edge perspective is more just we want to evacuate it and make it go away.
Yeah, so the amount of heat that you would produce would not be that large that you'd make a useful, reusable heat for the edge we expect. Yeah.
And then it's interesting what you were talking about with this, taking it outside, because then you wouldn't need to even cool the data center right? Because that was like one thing I noticed too. Is you're got these giant fans evacuating the heat into the room, and then the room had these air conditioners that were air conditioning the room. You're sort of processing that heat twice to get it outside. Where what's interesting with the liquid cooling aspect of it is, especially if you think about this inside of a an environmental remote cabinet, that won't necessarily have an air conditioner inside of it. It's got to get it out anyway. You could kind of have like what you'd have for an air conditioner that dissipates that heat over a much larger area. Interesting. Well, yeah, that's some good thought there. Maybe we should look at. It'd be interesting to see more of what they're thinking about from the cooling aspect, and maybe something that we could contribute is this touch point between modularity with MHS, and then what to do with cooling that also may need to be modular. For thinking like, okay, if I'm putting a CPU and maybe some accelerator cards in an edge chassis of some type, or even on the motherboard, I don't know. Can there be like a modular cooling approach to kind of go along with the MHS aspect? Am I off base? Am I nuts?
No, I think it's a good point, John. Actually, one other aspect that's usually discussed about this kind of liquid cooling system is related to maintenance, and then how you can guarantee that the system will operate in longer times. But for example, if we're discussing about having this modular system, what's the lifetime that you expect for this product? Like 5 years, maybe, and then you need to have some kind of update in hardware. I expect.
Keeping it cooler does extend the lifetime, right? So if you're not pushing the temperature envelope of the electronics, they should become more reliable than you're running them at. I even noticed that I've got a Raspberry Pi here, several of them at the house, but like I had it in a case, and what I was noticing is it was getting so hot here in Dallas that just when the case was on it, it was throttling because it was getting too warm. So if you take the lid off the top, even that made a big difference and let the thing just kind of run. Or just putting it inside of an enclosure of some form was causing it to throttle, which I didn't even think about until I was looking at like the temperature. I was like, oh, that's interesting.
For the liquid cooling, like if you're running a closed system, as I was saying, they thought that they need to refill the fluid at any point. Then you probably need some maintenance about the pumps and the valves within maybe 10 years or so, every 10 years. But about that, in that time frame, you already probably are planning on updating your hardware.
Right, exactly.
So you could have this kind of modular system where the user would never be doing any hardware maintenance there. They're just using that server, as you said, to do the training, and then they're using the AI application. And when the time comes, they could either update the whole system and then including the cooling with the hardware.
Right. And then the additional complexity doesn't really increase your failure rate because it would all be planned to be upgraded at the time of the hardware upgrade anyway. And so it's not really adding anything to your maintenance cost because you'd be replacing it.
Yeah, you can even refurbish it and continue to for the next application.
Yep. Interesting. So, are there any other topics you guys want to talk about?
Yeah, the only thing, I was thinking though, John, is I think the DCMHS is really about boards, component levels, not packaging necessarily. I mean, talk about form factors in terms of sizes, but I don't think they make any statements about how you package it. So I think this cooling aspect would be something about packaging of the components more than the like the motherboard or whatever, right? You can put it in whatever case you wanted to.
So like, are you talking like giving enough space for around the components to accommodate?
Well, no, I'm saying the DCMHS doesn't define the packaging, the sheet.
Right.
It's just the boards, right?
Right.
So, I mean, I think a lot of this stuff is probably about packaging more than, it's something. I'm not sure how, you know what I mean?
Yeah.
Yeah,
I mean,
I see your point, Greg.
It's a good
No,
topic. It's a good topic, but I don't think the DCMHS folks care how you're
Yeah.
going to package the modules.
Yeah, that's a good point. I think it might be not in that sense, not closely related there. Not the
Yeah.
best fit, maybe, yeah. Because it would, as you said, it would more related to this package and infrastructure that maybe they are not, maybe not their focus there.
So Craig, are you thinking this would kind of maybe fall back into our
Well, I think
group?
it's certainly the packaging of these components are things that are definitely in the edge kind of aspects, right?
Yeah. So basically, you have
especially if we talk about edge, not necessarily in terms of, our typical cell use cases, but there's many other use cases that you talk about for using AI equipment in the edge. You know what I mean?
right.
So yeah, I mean, I think that's totally appropriate. Something that, this group would probably be very interested in.
Very interesting. Yeah, because you'd want to, when you laid out the motherboard, you'd want to make sure there's, if you've got multiple modules and you wanted to put cold plates on them, you need spacing to accommodate that. Or, if you're putting in different components that you wanted to also cool. But like, as I think Lucas was saying, just even cooling the CPU actually helps cool the motherboard to some degree, just from the transfer of heat. And so, maybe it's even the layout of the board makes a difference in terms of, do you put all the hot stuff kind of together? Yeah, interesting. Any other thoughts around that topic? No. All right. Are there any other topics you guys want to talk about today? Going once? Going twice? All right. So should we call it a day then, gentlemen? Should we wrap?
Sounds good to me.
All right. Well, then we'll wrap. We'll see you all next month. Hopefully, I will get Dirk to get me this material, and then we can maybe delve deeper into this and maybe talk more about the MHS aspects of it. All right.
Cool.
If nothing else, then we'll we'll talk to you all next month.
Okay. Thank you.
All right.
Go on.
Thank you. Thank you very
Thanks,
much.
All right. Bye-bye.
Bye bye.